20 years ago, Mount Etna was erupting. I needed to go out into the field to collect some fresh lava samples. So I borrowed the suit from a colleague. You basically have to take the samples that are red hot within the lava flow and drop them immediately into a bucket of water so that they can then freeze. And then at that point you've got some very nice volcanic glass, which is perfect for analysis. Most of the volcanoes that the airlines were concerned about are in places like Alaska, and so they don't involve routes where you have to take off through a volcanic ash layer before you can go and fly. Of course, in the Icelandic eruption, we just had this fine ash cloud blowing around across Europe. People were simply unable to take off to fly through it. So it's a tremendous stimulus for the field. You know, the world has become such a well-connected place. Things like infrastructure has become sensitive to sort of external pressures. It means that even relatively small eruptions can have knock-on effects, which are of consequence to people living in Europe. A couple of things have changed dramatically in the last 10 years are the ease with which we can acquire very high-resolution satellite imagery. So there's a constellation of satellites out there measuring all sorts of things. And the second thing that's happened is that 10 or 15 years ago, you had to spend tens of thousands of pounds on a single sensor to make a measurement of a single gas species coming out of a volcano. Now you can, some of the sensors and detectors you can build are almost disposable. So you can build 10 or 50 or 100 and install these at volcanoes around the world. So the capacity for gathering real-time information has been transformed. I suppose the idea would be to have some sort of sufficiently good physical understanding of how a volcano works, that when a new volcano starts to show unrest, that scientists are able to make really very detailed predictions of how it's going to behave in the near future, just on the basis of knowing enough about its chemical composition. I suppose we're moving closer to that, but we're a long way from coming up with anything that's predictive, but we will be able to produce probabilities which could be used in long-term forecasting. Prediction is a bit like a weather forecast saying there's going to be a thunderstorm at 3 o'clock this afternoon, you must take an umbrella. And we're a long way from being able to say things like that. On the other hand, we will be able to say, if you're thinking of investing £10 billion in road and rail infrastructure in this region, then you should put it here rather than there, because there's a 70% chance this area will be inundated by volcanic activity in the next 50 years.